Welcome to this video on the BETTED Toolbox. This video focuses on the dairy supply chain tool. After a brief introduction of the project, the video highlights the main concepts of the dairy supply chain tool and the features of the tool itself. BETTED stands for Boosting Energy Transition of the Dairy Value Chain. It is a European project that focuses on facilitate companies belonging to supply chains in the dairy sector to foster the market uptake of energy efficiency measures, including the use of renewables and the deployment of heat pumps at the value chain level. Moreover, the project will also significantly contribute to the reduction of fossil fuels dependency, fast-forwarding energy transition. For further information on the project, please visit our project homepage at www.bettedproject.eu. The mission of BETTED is based on three pillars. 1. Establish a capacity-building program and community to transform organizational energy cultures, enhancing skills and knowledge in sustainable value chains, thus promoting energy transition for companies. 2. Implement tailored and easy-to-use tools engaging companies operating in the same value chain. 3. Provide policy and regulatory recommendations aiming at speeding up the energy transition. Let's talk about the tool. The aim of this tool is to help you to understand and minimize the overall specific energy consumption along the dairy supply chain. For this purpose, it allows to analyze the following energy requirement in storage and transport activities and time-temperature effects on the food quality and the resulting energy consumption. As for most of the tools, its target group are supply chain and environmental managers interested in the energy and environmental performance of their dairy supply chains. Let's take a closer look at this tool on the supply chain. The info sheet provides the basic information of the tool. In the input sheet, the user can fill in the data required by the tool. The data required regards series of processes involved in the production and supply of goods from the production of raw material until final goods are bought or used, i.e., from farm to fork. A supply chain encompasses the series of processes involved in producing and delivering goods, from the initial sourcing of raw materials to the final purchase or consumption by the end user. This network involves multiple companies operating at different stages, each with specific roles and objectives. The sample dairy supply chain illustrates a typical 7-stage process, from raw material suppliers to retailers. However, the specific supply chain may vary in structure. The user can adapt the analysis by omitting or combining stages to match the unique operations. It's recommended to focus on one representative product per analysis or use separate workbooks for different products if a more detailed view is required. 3 different macro categories of input data can be detected. Firstly, general inputs are required in terms of annual demand rate of the final product, space occupation of the raw material and final product, amount of raw material for producing a unit of final product. Then for each warehouse are requested data regarding the temperature, the consumption of refrigeration, the storage size, utilization, and time, and the production rate. Finally, for the transport activities, the user should provide information about the fuel, the distance and time, the refrigerations, the ambient temperature, and if any, the payload, which defines the maximum amount of product transportable per trip. As already said, these data should be provided for each stage of the chain. The stage considered are 1. Warehouse at the raw material supplier. 2. The transport between supplier and producer, considered as a single drop, which means single origin and single destination. 3rd, raw material and final product warehouses at the producer. 4th, transport between supplier and distribution center, considered as single drop. 5th, warehouse at the distribution center. 6th, transport between the distribution center and the retailer, considered as multi-drop, which means single origin and multi-destinations. 7th, warehouse and display area at the retailer. In this sheet, the results of the supply chain model applied to the input data are reported in terms of specific energy consumption, SCEC, by energy carrier. Furthermore, the specific economic and environmental impact are also reported, showing the costs and equivalent carbon emission per kilogram of final product. These results are reported for each link of the supply chain. This allows the identification of the stages with the highest energy consumption. This information, together with the average storage time below, can serve as a basis to support decision makers in the prioritization of the interventions. The toolbox contains two graphs. From this first graph, it is possible to observe the specific energy consumption of each energy carrier. The example in the slide shows in this case that producer and distribution center has the higher specific energy consumption, while the second graph shows the storage time for every stage. In this case, it is the producer the main contributor. This was our presentation of the LCA tool within the BETTED project toolbox. If you're curious and want to explore further, additional tool videos are available on our channel. Thank you for watching.